This lecture is continuation of previous lecture, that is compressible fluid flow through nozzle and diffuser. In this lecture, I will try to analyze the steam nozzle. To analysis of steam nozzle, first of all, if we consider a nozzle, suppose this is the nozzle, this is inlet section 1, this is the minimum cross section area, as you know, that is throat, and this is the exit. To analyze the steam nozzle, we have to consider the steady flow energy equation. Already we have discussed in earlier lecture, just previous lecture. So, as we know, the final velocity of the working fluid through nozzle V 2 is equal to root of H 1 2 into H 1 minus H 2, where we have considered the nozzle is adiabatic, horizontal. So, that is why Z 1 is equal to Z 2, potential part becomes eliminated, there is no heat flow. So, dq by dm is eliminated, there is no shaft work. Now, from the reversible adiabatic process, if we consider this is the equation 1, from the reversible adiabatic process, we can write dq is equal to dh minus v dp. Though this process is adiabatic, so this dq becomes 0. So, equation becomes dh is equal to v dp. If we integrate this from 1 to 2, though we know that for adiabatic process P v to the power gamma is equal to constant. If you get the value of v in this equation, then the after simple calculation we can get H 1 minus H 2 is equal to gamma by gamma minus 1 P 1 V 1 minus P 2 V 2. Is that clear? Suppose this is equation 2. Now, if we put the value of H 1 minus H 2 and put here, then we can get V 2 is equal to root of 2 gamma by gamma minus 1 P 1 V 1 minus P 2 V 2. Suppose this is the equation 3. Now, mass flow rate through nozzle, though we know that this is steady flow device. So, mass flow rate at section 1, that will be equal to section 2, that means A 1 V 1 by V 1 is equal to A 2 V 2 by V 2. So, if we consider mass flow rate m dot is equal to A 1 A 2 V 2 by V 2. Now, put the V 2 value in this equation from 3, we can get A 2 by a small v 2 root of 2 gamma by gamma minus 1 P 1 V 1 minus P 2 V 2. If this equation may be written as A 2 is equal to mass flow rate is equal to root of 2 gamma by gamma minus 1 P 1 V 1 by V 2 square minus P 2 V 2 by V 2 square. This equation again written as A 2 root of 2 gamma by gamma minus 1. If we take common, P1 by V1. So, equation will be what? V1 by V2 it whole square minus P2 by P1 into V1 by V2. This. As we know that Pv to the power gamma is equal to constant, we can substitute the value of V1 by V2 and V1 by V2 value in terms of P. So, final equation we can get mass flow rate is equal to what? Mass flow rate will be is equal to A into root of 2 gamma by gamma minus 1 into P1 by V1 into third bracket start P2 by P1 to the power 2 by gamma minus P2 by P1 to the power gamma plus 1 by gamma. So, this is the final equation of mass flow rate through nozzle, that is A into root of 2 gamma by gamma minus 1 into P1 by B1 third bracket start P2 by P1 to the power 2 by gamma minus P2 by P1 to the power gamma minus gamma plus 1 by gamma. Now, what will be the maximum discharge and when? To study this, we will proceed for condition for maximum discharge through a nozzle. So, as we know that from previous equation, mass flow rate through nozzle m dot is equal to what? M dot is equal to, sorry, that will be A2 into root of 2 gamma by gamma minus 1 into P1 by V1 third bracket start. If we consider P2 by P1 is equal to x, then x to the power 2 by gamma minus x to the power gamma plus 1 by gamma. So, this is the equation. So, this is the equation. When the discharge will be maximum, it is evident that m dot to be maximum, the expression of this third bracket will be maximum. That means, when this third bracket part will be maximum, m dot will be maximum. To having this m dot max, so what is the condition? So, condition should be have to be d by dx of this third bracket. That means, this third bracket part x to the power 2 by gamma minus x to the power gamma plus 1 by gamma, that is equal to 0. By simple derivation, we can get the x value at what the m dot becomes maximum. So, x is equal to what will be gamma plus 1 by 2 to the power gamma by 1 minus gamma, or you can say this is P2 by P1 is equal to that, or same equation we can write x is equal to 2 by gamma plus 1 to the power gamma by gamma minus 1. So, that is also P2 by P1. So, this is this equation and this equation, both are same. So, this is the condition for maximum discharge when P2 by P1 is equal to gamma plus 1 by 2 to the power gamma by 1 minus gamma, or 2 by gamma plus 1 to the power gamma by gamma minus 1. And the expression P2 by P1 for which the discharge through the nozzle is maximum is called the critical pressure ratio, and the pressure P2 at the throat, pressure P2 at this throat is called critical pressure. Okay. Now, if we put this P2 by P1 in this equation, we can get the maximum discharge through nozzle. So, maximum discharge, maximum discharge through nozzle, what will be? If we put this value x in the previous equation mass flow rate, then maximum discharge m dot maximum, that will be is equal to A2 root of gamma into P1 by V1 into 2 by gamma plus 1 to the power gamma plus 1 by gamma minus 1, or same equation can be written as A2 into root of 2 into P1 by B1 into gamma by gamma plus 1 into 2 by gamma plus 1 to the power 2 by gamma minus 1. This both are same. So, we can write this is the maximum discharge, this 2 is the maximum discharge for through the nozzle, the same equation. And you may note that when n is equal to 1.135, matlab gamma is an integer, if you consider this is the n, when n is equal to 1.135, that is for dry saturated steam, and value of x, that means P2 by P1 will be 0.578, and when n is equal to 1.3, that is super heated steam, then x will be is equal to what? Then x will be is equal to 0.546, and the velocity of the steam at the throat of the nozzle when the discharge will be maximum, when discharge will be maximum, the velocity will be what? The velocity can be written, the velocity is V2 is equal to, if we put the velocity V2 in this equation, then we can get maximum value, that means V2 max, that will be is equal to root of 2 into gamma by gamma plus 1 P1 V1. You may note this part, this too. So, I hope this lecture will help you, little bit help you to understand the nozzle analysis, that is a part of compressible fluid flow through the nozzle and steam. Thank you.